Hey YouTube, DC with DC's Gadgets here. Today we're going to draw up a beehive frame end and do CAD file on it, and then talk about how to generate a G-code program if you wanted to try to cut this on a milling machine or a CNC router. Someone in a beekeeping Facebook group had asked about this, so that'd be kind of fun to do this. So we're going to draw a 6 1/4 inch beehive end, and then we'll talk about doing G-code. So we'll start off making a box, and my finished part is going to be 1 3/8 by 6 1/4. So I've got draft site open, and I'm going to start with a square or a rectangle, 0, 0, and my endpoint would be 6.25. And I'm only going to make a half of this because it's a mirror image, so it'll be 0.6875. So there is half. Now I need to put the end cutouts in there. Not that one. I need to put the end cutouts in there. So we're 7/8 on this end, which is maybe 7/16 since we're half. So I need to cut out 7/16 by 7/16. So I draw a line at 0, 0.4375. And we're going to run it over to 0.4375, 0.4375, and we'll bring it straight down and snap. All right. Next I'm going to do the end line, which is 3/4, which is going to be 3/8. And it's not listed here, but we're going to make it 3/8 by 3/8. So another line at 6.25, 0.375. And we'll subtract 3/8 from 6 1/4 be 5.875, 0.375, and we'll just snap that one down also. Now the next feature we want is this offset here. 1 1/16 be 17/32. 17/32, it's 531, right? Gotta get the calculator out. 531, I was right. So, and we're going 3 inches to this top, and down here, get a little bit of an angle. Could be quarter, could be 3/8. I'm going to make it a 1/4 inch. So 3 inches and 3 1/4 and 531. So back to draft site. Let's start off first with a line at 3 inches. 3, 0. And we'll just draw it right up to here. And I'm just going to offset that 1/4 inch. And then we'll draw a line from here, 3.25, 0.531, and take that right to the end. All right, and then we want to get that angle, so we'll put a line from this point, that gives us our angle. And then we can cut out the stuff we don't need. So we'll go up here and we'll hit trim, and select this one. Select this line, and this line, and these 2 lines here. Now right click, we can get rid of this, and we get rid of this, and this. And then we can get rid of these 2 lines because we don't need them. So there's half of our part. So we mirror image this thing, we'd have the whole frame. If we try to cut this though, with an end mill or a round bit, you end up with a radius in all your square corners. And this area here, and this area here. So to avoid that, you get a couple options. You could drill a hole right in the corner. So to drill a hole big enough to cover your bit, you end up taking a lot of your metal off, or your material off. So what I like to do when I'm making things like this, if it's not critical to have the size, I'll typically offset my corners here 1/4 the size of the bit I'm using. In this case, we're using a 1/4 inch end mill. So I'll offset this 1/4 of that, so about 60 thousandths. So we'll hit offset 0.06. I'll come here and drop that, and here and drop that. Now I'll drill a hole at that intersection big enough to go right to that corner. So I'll just click here, go right to that corner. Right. So now when we cut this, because you're going to end up with a radius on these two pieces from your 1/4" end mill, let's go ahead and radius that. So we can fillet, radius 125, radius these 2 points. They fall inside that circle. So if we drill this hole beforehand, you're going to end up with a little bit of material void, usually full of propolis, but you're not losing a whole lot. So we'll do the same thing on the opposite side. It's offset 0.06. This one, and this one, and we'll put a circle on this intersection and make it just big enough to go to that point, and then let's find out how big that is. All right, so it's 169. So let's drill like drill a 170. What is this? First drill bit's a 171. So drill with 171 drill bit, and that'll give us enough clearance to get the corners. So we can get rid of this here, we'll get that, and we'll drop our lines. We'll get our lines. Now this is acting funny with the video capture running. Go over here and get rid of these 2 lines. And I'm going to put that fillet back to a sharp point because we're going to use that for our measurements later on. So we're going to hit fillet, radius 0, and click the 2 straight lines. And gives us our sharp corner. So now if we just mirror image this thing, we've got our frame. So let's go ahead and do that. We'll select the whole thing. Go over here and mirror image it. Click on this point. And go over here, we'll click on this point. And it asks us if we want to delete the original. We don't want to delete the original. Hit no and enter. And so there's our frame. So to hold this down to machine it, you're going to want to, I think you want to screw this down because you need to go around the entire perimeter of the outside of this. So let's put some holes in the center. You can put some screws in it. So pick a circle. Let's come down like 1.25 inches on the 0 line. And 0.08. Give you a 160 hole. And we'll do another hole. We knew that was 5.8, so let's go 5.4. So another hole, 5.4, and 0. Same thing. So we can screw this down to a block of wood and then go around the entire perimeter of the part without messing with our hold down. So that's your whole piece right there. So we can save this. We'll save it as, now you want to write a G code for this. So you got a couple different options you can do. You can write with offsets. Let's say you want to write your tool path to go center line of the tool, and you're running a 1/4" end mill. So come here and hit offset 0.125, and then offset every line. Take a little bit, and leave all of it. Okay, now, we're going to hook those lines together. A couple different ways to hook the lines together. If you come up here and hit your fillet again, hit radius of 0, and you click on these corners, it will fill those 2 corners in right here for you. Same here. Repeat fillet. My mouse is acting really weird. All right, repeat fillet again. Repeat fillet. Repeat fillet. So this is the path your actual tool is going to take. I'm going to do repeat fillet again here. And the bottom one. And you can write your G code to be this path now. Our 0, 0 is in the middle of this thing. We want to move it. You can put it wherever you want to. You can put your 0, 0 in one of these holes, or you can put your 0, 0 back here in this corner. I think if I were making this part, I'd probably do a 0 off this hole. It'd be easier to find a 0 on the machine, just drill in that way, and then everything's offset from there. Or you can put it in the corner, but I think I'd do it that way. So I'm going to make it 0 on that hole. So we just select the whole part, and come here and hit move, and center on this hole, and it becomes 0, 0. And we can zoom in. All right. So if I'm going to path this out and G code, the simplest one is just to follow this path here. I go up here and hit dimension, linear, and click on this corner here. So I may start at this corner and go all the way around it. So my point here is minus 1.375, 0.8125, and then just follow the pathway around. That's one way to do it. Or you can use an offset. You use G41, G42. Cutting wood, cutting softwood, I would recommend a conventional mill and not a climb mill. All right, so now we've got our part drawn and we've got an offset here. I'm going to go ahead and path this out with a G code following the offset. I'm going to run it as a conventional mill. In your softer woods, you're probably better off going a conventional cut. Try it. If it tears it up real bad, try a climb cut. So I'm going to use just a text editor. I'm using Notepad++. All right. I'll start out. We'll give it a name. Parentheses. We're going to call it medium frame end. Parenthesis. Next line. We're going to give it offset. We're going to use G56 for our offset. All right, the first tool we're going to use, we're going to go in, we're going to drill these holes for reliefs. So M6, tool change, tool 1, and we'll call it the 180 drill bit, wasn't it? I believe. 180 drill. Right, so the next thing we're going to do is move our tool to the center of the drill. So go up here and click on this. Dimensions back on my. So we're going to move. We're going to move at a rapid rate, G0, and we're going to center this hole. X equals minus 0.8725, and Y is 0.3775. Right. Now, depending on what kind of machine you have, if your machine can automatically run your Z-axis, you can put it in here now. If it can't, if you're going to manually do Z-axis, you just do a quill. So I'm going to assume you've got a machine that will automatically run Z. So we're going to run Z, still in rapid mode, to 0.2, and stop 200 thousandths above the part. Then we're going to go into a slower mode, G1, give it a feed rate of, let's say, 6 inches per minute. 6.0. Let's turn the spindle on, M3, 1000 RPM. And now we're going to run the Z down, minus 1.75. Let's say you're taking a piece of 2x2, and you stuck it in here, and you're going to run the whole thing. So when you get done, you can take it off and split it on a bandsaw, and you'll have, say, 4 or 5 pieces. And once you get to the bottom of the part, we go back into G0. G0, not O. It's a 0, okay. G0, and we're going to go back up to Z, 0.2, top of the part. And we'll do a rapid mode back to this one here. Your X will be the same, and your Y will be minus 0.3375. Y minus 0.3375. Then we go back to G1. Z minus 1.75, 0.75, G0, Z 0.2. And we'll do a rapid mode again, go over to these two holes. And the first hole is x 4.685, and y 0.315, G1, Z 1.75, G0, Z 0.2, and we're going to go to the bottom one. Your x should be the same, your y is going to be minus. So y minus 0.315. And G1, Z minus 1.75. So we drill the holes. Now let's do a tool change. M6, T2, we'll call it a 1/4 inch mill. So now we're going to go around the perimeter of this thing with a mill. I want to go around counterclockwise. I want to do a conventional mill. I'm going to start on this bottom corner. I don't want to start on the corner. I want to start off the corner. So my corner location here is minus 1.375. I'm going to start off it. So I'm going to take x minus, say, 2 inches, 2.0, and y minus 0.8125. Only problem is we're still stuck in G1, so let's go back up a second. We did a G1 there, then you go back to G0, Z0.2, and then we do a tool change. So we're in rapid mode. We moved it here, turn the spindle back on, and spin a little faster here. I want a spindle speed of maybe 7,000 RPM. If I can get 10,000, I'll go for that. We're bring out a machine. We're going to start with 7,000, see how that goes. We're going to bring the Z down, minus 0.1. Now we'll go back into here, G1. I'm going to leave the feed rate at 6 for right now. I'll play with your machine. We'll just leave it at 6. For G1, we're going to move the X from over here down to this first intersection. So moving X, and you go to 1.7859. All right, next move is going to be to this intersection. X is 2.0359. Y minus 0.656. All right, now move to the next position. X 5.125. Y is not going to change. In the next position, your Y is going to change, your X is not. So your Y is going to be minus 0.25. Now we're going to move the X to this intersection here, 4.75. Then we'll move the Y up. Should be 250. Yep. Y 0.25. X 5.125. And Y 0.656. X 2.0359. Move the X and Y together. X 1.7859. Y 0.8125. The X to the corner. X minus 1.375. Move the Y down to here. Y 0.3125. X minus 0.9375. Y is going to be minus 0.3125. X minus 1.375. And then I'm going to come off the part. So my y here is actually 8125. I'm going to go off the part. So I don't get that. Make sure I cut the whole corner off. I'm going to go to a y like minus 1.2. Y minus 1.2. Now I'll go into a G0. And I can either come up 0.2 and move over, or I can just go back to my original position over here with my 4.685. Wrong one, over here. X minus 2. So go G0, and then I can copy everything from here down. No, let's do this. If we move the M3 above it, let's cut this out of here. We'll put it in here and delete that line. So now if you copy everything from below the M3 S7000 and paste it, and just change your Z depth 100,000 each time until you get to the end, you'll have the whole thing. And then let's just go ahead and put this at a Z 0.2. And we'll give it an M30 to end. And we'll save the program. So that's the whole program. Goes all the way around. Play with it. Try it out. See what you think. Send me some feedback.